Okay. Let me go ahead. Let me do like this. Mark. So I'm only missing 3. That's pretty good. Present. Okay. 6. Let me see. It's correct. Okay. Let me share my screen. Optimize video. All right, we'll start here. All right, so greetings, scholars. We are at the end of week 7. So what that means is that this Sunday you can anticipate exam 2 to become available. It's really just exam 2. There's not really a midterm exam. It's just exam 2. Your midterm grade is going to be based on everything that's been due leading up to exam 2, including exam 2. All right, so I do plan to include that into your midterm grade. Okay, so today we are going to be doing a homework session for section 1.6. Going through as many homework questions from this section as we can together. We got through about half the questions in my previous class. So let's work on the 3 p.m. Okay. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 9.
And also, I'll check attendance again around the 15-minute mark for anybody that came in after I did my first wave. I'm looking for 3 students, so I just want to give them a chance to get into the waiting room. So you know, if they're there and if you're in communication with them, just say, hey, just wait until about the 15-minute mark. If they just go into the waiting room and wait, they'll get in. Okay. So given this f, we're asked to find f of 4, right? So the open circle, that's composite. That means f compose f. That means the second function inside the first function, right? So first, let's go ahead and find f of 4, right? So that's going to be what? 12 minus 3 is 9. And then we take that result and plug it back into f. So then f of 9 is going to be 27 minus 3. I think it's 24. Okay. 24. Okay. Hey, Google, give me another random number.
Here's a random number, 51.
Hey, Google, give me a random number between 1 and 19.
4.
Okay, find f plus g, f minus g, f times g, and f divided by g in their domains. So if we're saying f plus g, here we don't have any like terms, so we're just adding all the terms together. X to the power of 3 plus 4x squared plus minus 2x plus 4. Okay. As usual, if anything isn't clear, if you have questions about anything, feel free to unmute yourself to get my attention or type it in the chat and we can talk about it. Okay. So the domain of f and g are both all reals. So all reals intersection all reals should be all reals. There's no restrictions on any of these functions. Okay. F minus g, okay, no like term, so we just need to make sure that x cubed has a negative. So we're going to say 4x squared. Nope. 4x squared minus 2x plus 4 minus x to the power of 3. All reals again. There we see. F times g. So we're going to distribute x cubed into f. If we distribute x cubed, we get what? 4x to the power of 5 minus 2x to the power of 4 plus 4x to the power of 3. And then it's still just going to be all reals. So then we say f divided by g. There's no factoring or there's no cancellation even if we were to factor. So we don't have to do all that. 4x squared minus 2x plus 4 minus 2x plus 4 divided by x to the power 3. I think that's okay. So the only restriction here, remember with rational functions, we cannot divide by 0. So in general, for a rational function, the domain is all reals except any x that makes the denominator 0. 0 makes the denominator 0. So we want everything except 0. That's captured by option B. Okay. Hey, Google, give me a random number between 1 and 19.
17.
So find the f and g such that f compose g gives us h. And we're given that the inside function is x minus 9. So we need a function so that when we plug in x minus 9, we get h, all right? So we're going to say 9, the reciprocal function, 9 over x. Hey, Google, give me another random number.
Here's a random number, 2.
Find each of the following values given that this is our f and our g. Okay. I'm tempted to do this in my calculator, but we might be able to do them quickly without the calculator. So, okay, this means f of -1 plus g of -1. I think I'm gonna use my calculator actually. It's not too difficult, but I don't feel like trying to keep all that in my mind. So I'm just gonna use this. My f is 1 over the square root of x plus 2, square root of x plus 2. Okay. My g is 3x plus 2, so 3x plus 2. Okay. So then I want to call on, the first one is f plus g of -1. So I'm going to do f of -1 plus g of -1. And I'm just going to use that. We get 0. So I'm just going to do 0. F minus g of 0. So I'm just going to call on a function. I want to say f of 0 minus g of 0. Okay. Type in exact answer. Okay, we might need to write this one out. Okay. So then f of 0 is 1 over the square root of 2. G of 0 is just 2. Okay. So we have 1 over the square root of 2 minus 2. Can we just leave it like that? Let me see if I can just leave it like this. Okay, that's fine. F times g of 2, so I'm just going to say f of 2 times g of 2. Let's see, can we do it in the calculator? We might be able to. Okay. So if I call my function f, we want to say f of 2. I think this is okay. If we get this wrong, I got a change I can do. F of 2 times g of 2 should be 4. Let's just go with 4. Okay. And then f divided by g of 1. Okay, so that's going to have another decimal. So f of 1 is going to be what? 1 over the square root of 3. Let's go ahead and capture that. So we're going to have 1 over the square root of 3. Okay. And then g of 1 is going to be 5. So then if we were to rewrite this, this would be what? 1 over 5 times the square root of 3. Let's just write it over here. 1 over 5 times the square root of 3. Usually we need to rationalize, like usually we don't leave radicals in the denominator, but I know sometimes I do accept that as a result. So I'm just going to submit this. Okay. All right. Hey, Google, give me a random number between 1 and 19.
17.
Why do you like 17 so much? Okay, so we'll just do the one after 17. Express a given function h as a composition of two functions, f and g, so that f composed g equals h. Let's see. Like if I were doing it, my g would be x cubed minus 8, as in d. D looks good, all right? X cubed minus 8, let's go with D. Okay. Hey, Google, give me a random number between 1 and 19.
14.
Okay. The functions f and g are given. Evaluate f composed g and find the domain of the composite function. Okay, so f composed g means the second function inside the first function. So what I'm going to do is write the first function like normal, square root of x minus 2. But first thing we're going to do is replace each x with a blank parenthesis. So we got x minus 2, right? And then now into the blank parentheses, I put the function g, which is 1 minus 5x, okay? Then we want to simplify. So like combine like terms and all that kind of stuff. We don't need to distribute a negative. We don't have multiplication over addition or anything like that. 1 minus 2 is negative 1. So that's going to be the square root of negative 5x minus 1. Let's get rid of this other stuff before we submit this. Okay, that looks decent. Okay. And then the domain. So to find the domain of a composite function is a 3-step process. First step is find the domain of the inside function. The inside function in this case is the g of x, which is 1 minus 5x. That's a linear function with a y-intercept of 1 and a slope of negative 5, right? So that means the domain is all reals. So the domain of the inside is all reals. Then we want to find the domain of the simplified function. So we got a square root. Remember, we cannot take the square root of negative numbers, so that radicand needs to be greater than or equal to 0, right? So that negative 5x, so we have negative 5x minus 1, it needs to be greater than or equal to 0, right? So then if we keep working, solve for x, I'm gonna add the 5x and then divide by 5. That'll give me a negative 1 by 5 needs to be greater than or equal to x, I think, right? Because if we add the 5x and then divide by 5, we get this, right? So then the domain of our inside function was all reals. The domain of our simplified function is x is less than or equal to a negative 1 by 5. So then this set intersection all reals is just this set. Any set intersecting all reals is itself, right? So then we just need to put this in interval notation. So if x is less than a negative 1 by 5, that means, you know, if we plot negative 1 by 5 on a number line, do we want to keep the numbers to the left of negative 1 by 5? Or do we want to keep the numbers to the right? All right. If x is less than, we want to keep the numbers to the left. So we're going to capture that by saying negative infinity up to negative. Let me get rid of these items here. I think this looks good. Oh, let's see if we can. Oh, greater than or equal to 0, right? So this needs to be a square bracket. It can be 0. So this needs to be a square bracket. I made that same mistake earlier. Okay. Because we can take the square root of 0. So it is defined when the radicand is 0. So that means we can be equal to this number. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 10.
Okay, let's look at 10 right here. The functions f and g are given. Evaluate f compose g and find the domain composite. Okay, f compose g. So the second function inside the first function. So let's write the first function like normal, but replace each x with a blank parentheses. So we're going to have 5 over x plus 1. And then into the blank parentheses, we put the second function, which is 5 over x. So then here, this is what's called a complex fraction because we have fractions within another fraction. So to clear it out, what we're going to do is multiply by 1 in the form of the LCD over the LCD. All right. So if we just look at the interior fractions, the LCD is just going to be x. So we're going to multiply by 1 in the form of x over x. Okay. So then when we do this, on top, we're going to get 5x. On bottom, if we distribute an x, that's going to become 5 plus x. Okay. So then that looks a lot better than what we had before. I'm going to get rid of these notes. And I'm going to go with this. Okay. And then the domain. Oh, yeah, I am definitely slowing down. Okay. So the domain of a composite, first we start with the domain of the inside function. The inside function is g. So that domain is everything except 0. And then the domain of our simplified is everything except -5, because -5 is going to make a 0 in the denominator. So then the first set is everything except 0. Second set is everything except -5. The intersection of those two sets is going to be everything except -5 and 0, right? So long story short, we want all reals except -5 and 0, because at some point during this process, -5 and 0 make a 0 in our denominator, okay? So let's see. If we want everything except -5 and 0, so the far left is going to be -infinity up to -5, okay? And we combine this with union, right? And then we want to say from -5 to 0, union. And then we want to say 0 to infinity. And that's how we capture all reals except -5 and 0. Okay. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 6.
6 is here. Okay. Use the diagram to the right to evaluate G compose F, then evaluate G compose F of 2 and G compose F of -3. Okay. So simplify your answer. G compose F. So F is inside of G. I think I'm going to write it out like I did before. So our outside function is G, so I'm just going to start there, but I'm going to replace each x with a blank parentheses. So I'm going to say 2x plus 5. And then inside those blank parentheses, I'm going to put F. Remember the second function inside the first. So that's going to be x squared minus 2. And I'm going to go ahead and simplify this guy. So if we distribute that 2, that's going to become a 2x squared. Minus 4 plus 5 is plus 1. Okay. And I'm going to get rid of these notes. I feel good about it. Let's go with it. Okay. So then G compose F of 2 means G of F of 2, right? So let's find F of 2 first. So if we plug 2 into F, that's going to be 4 minus 2. That result is a 2. Then we take that 2, plug it into G. That's going to be 4 plus 5 is 9. So that result should be 9. Okay. Then we're asked to find G compose F of -3, right? So first we plug -3 into F. That's going to be 9 minus 2 is 7. Then we plug 7 into G. That's going to be what? 14 plus 5 is 19. let's go with this. God is good. Okay. Hey, Google, give me a random number between 1 and 19.
4.
4. So I will say, if we do get through all of these questions and we finish early, I'll let you guys go early. I'm okay with that. The functions f and g are given. Find each of the following functions and state its domain. Okay. So we're basically adding, subtracting, multiplying, and dividing. Okay. So notice if we say f plus g, there are no like terms. So we just need to write out the terms added together. So square root of x, we need to get out of the square root, plus x minus 17. Okay. Okay, let's keep going. What's the domain? So the domain of f is 0 to infinity, including the 0 with the square bracket. The domain of g is all reals. So 0 to infinity intersection all reals is just 0 to infinity. F minus g. Okay. So f is what? Square root of x. Get outside the square root, we're going to say minus. Now, if we're saying minus g, we need to distribute a negative into g. So that's going to be a minus x and then a plus 17. So the trick there was to catch that we distributed a negative into g. I know students tend to miss that. Okay. Let me see. So the domain of f is 0 to infinity. Domain of g is all reals. Only restriction on the final is the same as f. So the final result should just be 0 to infinity. Okay, f times g. F times g, so we're distributing that square root of x. So I'm going to write that first one as x times the square root. X times the square root of x minus 17 times the square root of x. Okay. Same 0 to infinity, right? Yeah, because that's the only restriction. Okay. Hey, I'm slowing down. F divided by g. F divided by g, okay. So the numerator is the square root of x. X minus 17. Okay. That looks good. I'm just go with this. Okay. So we still have our original restriction of 0 to infinity, but then also we got to make sure that the denominator is also not 0. So we had to throw out x equal to 17. So it's still 0 to infinity, but then we have to throw out 17. Okay. So we're going to say square bracket 0 to 17. Since we don't want 17 to get to parentheses, then we're going to say union. Again, parentheses 17 to infinity. Infinity always gets a parentheses in this context. Okay. Okay. Whew. Okay. Hey, Google, give me a random number between 1 and 19.
8.
8. I'm gonna try to skate. Given this f and this g, evaluate the expression shown below. F compose g of negative b. Okay. So let's write f of x, which is 4x plus 9. Nope. And replace each x with a blank parentheses. So 4x plus 9. And then into the blank parentheses, we're going to put g, which is 2x squared minus 7. Again, I'm going to use blank parentheses, 2x squared minus 7. Nope. Minus 7. And then we're replacing x with negative b. Okay. So if we simplify, negative b squared becomes a positive b squared. If we distribute that 4, that's going to be what? 8b squared minus 28 plus 9. Okay. And then if we combine like terms from there, 8b squared, what is that, 19? So minus 19. Hey, Google, give me a random number between 1 and 19.
17.
Okay, so let's go ahead and do 19. Let's see, you work in a department store in which employees are entitled to a 10% discount on their purchases. You also have a coupon worth $20 off any item. Write a function that represents the price of the item after applying a discount of 10% where X is the original price. So if it's 10%, if it's discounted by 10%, you're not paying 100%, you're only going to pay 90%, right? So 90% of the original price, so we're going to say 0.9x. 0.9 times x. Okay. Write a function that represents the price of the item after applying the coupon where X is the original price. We said $20 off, so the original price minus $20. We're going to say X minus 20. Use the composition of your two functions from A and B to model your cost function for an item if the clerk applies the discount first and then uses a coupon. So the discount first is what? A. So that's our inside function. So we need to put A into B. All right, because we want to do the discount first and then apply the coupon. So if we put the result from A, if we do, this is basically G composed F. All right, so it's going to be 0.9x minus 20. So 0.9x minus 20. Okay, let's go with this. And then part D is the reverse, right? If they apply the coupon first and then the discount. So if the first one was G composed F, that one's going to be F composed G. So then we're going to have 0.9 times X minus 20. So it's going to be 0.9 parentheses X minus 20, but then let's simplify. This is going to be equal to 0.9X minus, what is that, 18? So then is that 1.8? Probably minus 18. Yeah, that makes sense. Minus 18. Hey, Google, what's 0.9 times 20?
0.9 times 20 is 18.
Okay. So let's get rid of our notes here. Okay. Let's hit enter. Okay. So notice in the first one in C, where we apply the discount first, we got 0.9x minus 20. But if they apply the coupon first, we get 0.9x minus 18. So which one gives us the bigger discount? So then for E, use the composite functions from CD to find out how much more an item costs if they apply the coupon first. All right. So then we can just basically say the result from, let me think about it. I think we can just say C minus D to get that result, right? If we say C, it looks like we're paying $2 more, or if they apply, yeah, we're paying $2 more, right? Because if we say C minus D, we basically get -2. So that means we're paying $2 more if we apply the coupon first. So that's interesting. The order in which you apply these discounts affects how much you pay. Okay. We got a solid 10 minutes. Give me just a moment. Hey, Google, give me a random number between 1 and 19.
3.
Given this f and this g, basically add them together and determine the domain of each. So combining like terms, there are no like terms, so we just add all the terms together. 3x squared plus x minus 3. Okay. The domain of f is all reals. The domain of g is all reals. All reals intersection all reals is all reals. F minus g. So, okay, x minus 3 minus 3x squared. X minus 3 minus 3x squared. Okay. What's the domain of f minus g? All rows. Same reasoning as the previous example. F times g. So we need to distribute that 3x squared. We're going to get 3x to the power of 3 minus 9x squared. Okay, let's go with this. Oh, I don't know if, yeah, I think I did my second wave. I totally forgot. I'm pretty sure I got somebody. Yeah, let me get them. Let me update my attendance. That one should be all rows as well. F divided by G. There's no cancellation that's going to happen, so we're just going to do F divided by G. So we're going to hit division, x minus 3 over 3x squared. Now the restriction here as far as the domain, remember we cannot divide by 0. So I think when x is 0, that makes the denominator 0. So we want everything except 0, which is going to be captured by C. Okay. Yeah, that's fine. Okay. Hey, Google, give me a random number between 1 and 19.
14.
Let's see. So let's do 15. Doesn't look like we're going to finish early. For the functions f and g, find f compose g and its domain f of g. Okay. So g goes inside of f. So that's going to be the absolute value x squared minus 7. Okay, I'm gonna go with this. All right. Okay, so to find the domain of a composition, first we find the domain of the inside function. The domain of g is all reals. Then we find the domain of the simplified function. I think the domain of the simplified is all reals as well. There are no restrictions, right? So then all reals intersection all reals is going to be all reals. So negative infinity to infinity. Hey, Google, give me a random number between 1 and 19.
8.
Okay, so let's do 11. The functions f and g are given. Evaluate f composed g and find the domain of the composite function. F of g. Okay. So let's write f of x like normal. And let's start with replacing each x with a blank parentheses. So the square root of x minus 6. Okay. And then into the blank parentheses, we put g, which is 3 minus 2x. Okay. Then we want to just basically expand and simplify. So I'll do my square root again. We're not distributing here, so 3 minus 6 is going to be what? Negative 3. So it looks like it's going to be a negative 2x minus 3. That's it. Okay. Good. Okay. So for find the domain of a composite, first we find the domain of the inside function. That domain is all reals from G. The domain of the simplified, we can't take the square root of negatives. So that radicand needs to be greater than or equal to 0. I'll take some notes here. So we got this negative 2x minus 3 needs to be greater than or equal to 0. Okay. So if we solve for x, I'm going to add 2x to both sides and divide. I'll get a negative 3 by 2 needs to be greater than or equal to x. Okay. So if x is less than, let me see, the all reals intersection this set is just going to be this set. So if x is less than a negative 3 by 2, that means we want all the numbers to the left, which is going to be what? Negative infinity up to negative 3 by 2. Okay. Oh, and because it can be equal to 0, we need to use a square bracket. Okay, we got time. Let's do like maybe 1 or 2 more examples and then we'll call it a day. Okay, I feel okay about this. Let's go with this. Hey, Google, give me a random number between 1 and 19.
11.
So let's do 12. Given this f and g, find each composite function and describe the domain of the resulting function. Okay. So f of g. So let's do our outside function first, which is going to be 8 minus 4x. This is going to be our last one. And we're going to replace the x with a blank parentheses. Into the blank parentheses, we put the second function, which is g. So it's 8 plus x squared. X squared. Okay. And then we simplify. So we're going to distribute that negative 4. That's going to give us 8. What is that? Minus 32? Minus 4x? 4x squared. Okay. And then 8 minus 32 is 30 minus 6 is 24, negative 24. So that looks like it's going to be a negative 4x squared minus 24. I'm just going to go with this. Hopefully it's good. Okay. The domain of f composed G. So the domain of G is all reals. The domain of the simplified is all reals. So this one's going to be all reals. Okay. G compose f. Okay, so let's start with the outside function, which is going to be 8 plus x squared. But remember, we're going to start by replacing each x with the blank parentheses. And then what goes into the blank parentheses is f, which is 8 minus 4x. Okay, so we got a squared, so we need to FOIL. That's going to be what? 8 and 8 is 64. 8 times 8 is 64, so minus 64x. And then plus 16x squared. Okay. Then if we combine like terms, I got my 16x squared. I got my minus 64x. 72 plus 72. Let me get rid of my notes. Okay. The domain of F is all reals. The domain of the simplified is all reals. So this should be all reals. F of F. Okay. So let's start by writing the outside function, but using our blank parentheses. So we're going to say 8 minus 4x. 8 minus, come on. 8 minus 4x, but then into the blank parentheses, we're going to put another 8 minus 4x. And then if we simplify, we're going to have 8 minus 32 plus 16x. Yeah, plus 16x. Then that's going to be equal to 16x 24. So minus 24. Okay. And I think it's all reals for the same argument as before. No restrictions anywhere. Get you guys out of here. G of G, so we're going to write G like normal, but use our blank parentheses, 8 plus x squared. Nope, blank parentheses. Then into the blank parentheses, we put G again, which is another 8 plus x squared. Okay. So then if we expand this, the first 8 persists. If we FOIL, that's going to be what, 64? So plus 64 plus 16x squared plus x to the 4. Combining like terms, 72. So this becomes 72. I think that's the only change. Okay. And no restrictions anywhere. So the domain we're going to say is all reals. All right, gentlemen. Are there any burning questions before we go our separate ways? I don't think we wrote anything. Going once, going twice. Forever hold your peas and rice. Okay. So if there aren't any burning questions, yeah, just anticipate your exam 2 to become available this Sunday over, it's essentially the second half of chapter 1, right? But you can't do the second half without knowing the first half. And again, if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. See you next week, same time, same place, guys. Take care. Peace.